first video is going to be on whole number multiplication. And so in 4th grade, they are introduced to the area model for multiplication. And then in 5th grade, mastery of the standard is being able to transfer that knowledge to the standard algorithm for multiplication. So in this video, we are going to solve both ways at the same time so we can see the connection between both of our methods that we're going to use. So when you are solving using the area model, you are decomposing based by place values. So in the number 26, I know that there are 2 10s, which is 20, and 6 1s, which is 6. And then in 31, I have 3 10s and 1 1. And essentially, we're breaking it up into smaller parts that are easier to multiply by, which is also what you do within the standard algorithm, but this is much more cut and dry and easier for the kids to see. So I am going to label, my 20 plus 6 on the top of my area model, so on my length, and then I'm also going to label my 30 and my 1 on the other side of my area model. And so area, this also connects the area's multiplication. So I have each of my small areas that I'm gonna find. So my length here is 20 times 30, which we know is 600. I have 30 times 6, which is 180. I have 20 times 1, which is 20. And then I have 6 times 1, which is 6. Now, what's interesting is all of these partial products that we see within our area model are also going to be found within our standard algorithm. And so the standard algorithm is eventually where we want all of our kids to get, but they're introduced to this first so they understand the place value behind it. Like here, I multiplied 10s times 10s, which gives us hundreds. And that same idea is also evident in the standard algorithm. So I'm going to solve this. We're going to do our 26 copies of 1 first. So we're going to start with multiplying our 6 times 1, which is 6. And you can also connect that that is also found in our area model. The next thing I have is my 1 1 times 2 10s. That is also found in my area model. That is 20 or 2 10s, which is why the 2 goes in the 10s column. And so my first partial product here is 26, which also matches this row here in my area model. I'm gonna finish this off. Let's do blue. I now have this 3 that's in the 10s place. I don't ever tell the kids, oh yeah, you just put a 0 here. They know why the 0 goes there. They know it's because this 3 is in the 10s place, and anything times a 10 ends in a 0. So now we can do 3 10s times 6 1s. That is 18 10s, or 180. So we put our 8. We carry our 1 in the hundreds because 18 10s is 180. And then I do my 3 10s times my 200, or my 2 10s, which gives us a 6 in the hundreds, which is here. The problem is we carried this 100 in the hundreds place. So I do have 600s plus this extra 1, which makes it 700s. And that part seems to be the hardest for them to understand when transitioning from the area model to the standard algorithm. In the standard algorithm, you're doing your multiplication and your addition at the same time, whereas here, you do all your multiplication first, then you do all your addition. That seems to be the hardest transition for them. But in my area model, if I went and added this together, I would get 780 as my first partial product, which I also have represented here, and then I would have 26 as my second partial product, which I also have here. And so when I add these together, I get 806, no matter which method that I use. And so my goal is to transition them from feeling like they have to use this to feeling more confident with the standard algorithm versus having to use the area model. Like I said, the biggest hurdle that I find is they don't understand that they're doing both the multiplication and the addition at the same time here, whereas here they're doing them separate. That seems to be the biggest issue. But let me know if you have any questions.